Looking at the scale of these stones, it is easy to assume that Bronze Age builders lacked the capacity to move them. The sheer numbers suggest a project that defies the era. 2.3 million individual blocks aligned to true north within a fraction of a degree. This statistical weight often leads to speculation about extraterrestrial help, lost advanced civilizations, or ramps kilometers long that would have required more material than the pyramid itself. However, the construction methods are not a mystery. The records survive. We have simply been looking at the wrong part of the record. For generations, scholars expected to find religious scripture. When they looked at engineering notes, they saw prayers instead. Solving the puzzle requires us to change our perspective, to stop reading these records as sacred texts and begin treating them as industrial manuals. Most reconstructions of Giza assume workers dragging these stones across miles of waterless desert. That assumption changed with the discovery of the log of Merer. This 4,500-year-old work log is a daily timesheet for a crew of boatmen, detailing where they slept, what they loaded, and where they delivered it. Merer records his team sailing limestone blocks directly to a harbor at the Pyramid Plateau's foot, a site that has been a dry desert for thousands of years. In 2024, satellite radar confirmed Merer's account. It detected the Aram Branch, a hidden 64-kilometer buried Nile branch flowing past the pyramids. Radar shows the monument's raised causeways running perpendicular to the vanished river, terminating on its ancient banks. These causeways were not religious roads, but unloading ramps. The end structures, long classified as ceremonial valley temples, were the docks of a major port. The pyramids were waterfront projects. Our confusion only arose because the river migrated east, leaving the logistical infrastructure buried and only the stone monuments visible. A Deir el-Bersha tomb painting shows 172 men hauling a massive statue on a wooden sledge. At the leading edge, a man pours water directly onto the sand. Egyptologists traditionally interpreted this as a ritual purification, a priest blessing the ground as the statue passed. A 2014 study showed the physics at play. Adding a specific amount of water causes sand grains to bridge together, turning a crumbly surface into a stiff load. This simple technique drops the required force by half. By controlling the friction of the sand, that single worker performed the physical labor of 86 hauling men. This mastery of leverage also solved the problem of steep inclines. In 2018, a mission at the Hatnub Alabaster Quarry found a specialized ramp used to pull multi-ton stones out of the earth. The system used a central ramp flanked by stairs and wooden post holes. By wrapping ropes around those sexed posts, the workers created a force multiplier, pulling blocks up slopes 3 times steeper than once thought possible. These discoveries suggest that what we once viewed as brute muscle was actually a sophisticated application of physics. We see the same logic at Saqqara, the site of the first colossal stone monument in history, the Step Pyramid of Djoser. Near the pyramid stands a massive stone enclosure, previously labeled as a fortress or a cattle pen. Hydrological analysis shows the structure sits directly across a seasonal riverbed. It is a check dam, built to capture flash floods and settle out heavy debris. Adjacent is a trench with deep compartments, matching the sequence of a modern water treatment plant, designed to filter and purify that captured floodwater. This purified water was piped into vertical shafts inside the pyramid. The hydraulic pressure floated a wooden platform, carrying stone blocks upward. Using water weight as a lift allowed stones to rise through the monument's center, returning for the next block when lowered. This suggests the first pyramid was raised by hydraulic engineering nearly 5,000 years before the modern word for it existed. The most impressive feat at Giza is the organization required to manage the workforce. Excavations revealed an entire planned city for thousands of workers, supported by industrial bakeries and a nationwide supply chain for livestock. Skeletal remains from the site show healed fractures that were professionally set, proving the crew had dedicated medical care. Their survey work was equally disciplined. They used written mathematical formulas to compute slope and aligned the base of the Great Pyramid to true north by tracking rod shadows on the day of the equinox. Building a pyramid required a synchronized supply chain and a managed workforce operating with precision for an entire generation. While the vocabulary for these construction techniques was lost, the physical evidence of the system likely remains inside the stone. Cosmic ray muon scans of the Great Pyramid have detected a massive 30-meter void and a sealed corridor hidden behind the outer blocks. Official reluctance to explore these spaces often stems from viewing the monument as an untouchable sacred tomb, where voids are seen as unremarkable gaps. In an industrial context, these voids represent the discarded architecture of the build, internal ramps and lifting systems left behind when the casing was sealed. For centuries, we have searched for answers on the outside of the monument. The solution to the pyramid mystery remains sealed inside the monument, waiting for us to look at it as engineers.